Oh, good evening and welcome to Neptune All Night, live from California at the Jet Propulsion Laboratory and from here in Philadelphia at the studios of WHYY Television. My name is Sedge Thompson and I'm sitting at a table here with a number of scientists, astronomers, and science fiction writers who will keep you company throughout the night as we present our coverage of the Voyager 2 flying past the planet Neptune at the closest point before Neptune then leaves our solar system and heads out onto deeper space. We'll be here throughout the night with the updates from the Jet Propulsion Laboratory at the top of each hour. And throughout the night, we'll hear comments from writers and thinkers throughout the country. We'll hear from scientists at the Jet Propulsion Laboratory itself. We'll hear from Dr. Science, the comedian from Iowa, David Osmond from Firesign Theater, with George Tirebiter from Seattle, all linked in by satellite tonight with us and with you. Also tonight, we'll be hearing from the guests here in the studio, including Jesko von Puttkamer of NASA. He's in the Strategic Planning Office. He's in the Office of Space Flight. We'll also hear from science fiction writer and author of Pantera, Judy Moffett. Also here with us is Jack Horkheimer, who is known as the Star Hustler throughout the PBS system and is the director of the Miami Space Transit Planetarium. And from the Franklin Institute Science Museum, we have Derek Pitts, Mike Weilbacher, and Joyce Town, all to talk to us tonight about the significance of Voyager flying past Neptune tonight. We'll also be learning more about the photographs that we see that will be coming in. First of all, I think we should figure out exactly what it is we have learned so far. Mike Weilbacher from the Franklin Institute, can you bring us up to date on what has been the most surprising element about Neptune so far?
I think there are several things to talk about simultaneously. One is the surface of the planet itself. It's proving to be a very lively surface. That great blue spot that seems to change in size as we once it was the size of Mars, now it's the size of Earth, but it seems to be 1/4 of the size of the planet as you look at it. So it's a lively surface. That's one thing that we'll be bringing you updates on as we talk about Neptune. Also, the number of moons. As we knew, Neptune had 2 moons, Triton and Nereid, before Voyager launched itself, and now suddenly it's up to 8, I think is the latest count. Two were found today. So the number of moons, and then of course the arcs and the ring arcs that encircle the planet. So those are some of the main features that Voyager's been finding.
This is a night where we're acquiring knowledge that is just brand new for everybody. Scientists tonight will be trying to assess it, but of course clearly we'll be analyzing it over time tonight. We're seeing footage right now of the various planets that Voyager has passed since it was launched in 1977. Jesko von Puttkamer from NASA, was it expected that Voyager 2 would get this far to Neptune?
Not really. When you talk to the actual people who built Voyager, even they are probably amazed of how well their 2 machines did. We have 2 machines, Voyager 1 and Voyager 2. Tonight, of course, is a night of Voyager 2, and they weren't really built to last that long. They were built to last just a few years, maybe 1 or 2 years, and now it's already 12 years. And they're in fact more capable right now than they were at the launch.
How do you mean more capable?
Well, because of the advance in the state-of-the-art in software technology, in more sophisticated maneuvering, the navigators and the controllers learned how to improve the spacecraft over billions of miles remotely. So even if it is 60s technology, which is flying out there, it is more capable than it was at the time of its launch when it was brand new, even if, of course, the propellants are getting depleted, the plutonium is getting depleted, so we are running out of power and out of fuel. But in capability, in performance ability, it's more able to do things than it was 12 years ago.
We currently are seeing a picture that is being sent by Voyager from Neptune. The image, of course, taking now at this point about 4 hours. So this is, in fact,
yeah, that's a star.
That's a star. That we're
Sigma Sagittarii, photographed through the ring region in order to see whether there is an occultation. There are, I think, about 28 pictures which keep coming in about this time now.
And can you explain the occultation?
Well, maybe our astronomer should do that.
Derek Pitts from the Franklin Institute.
Good evening, Sedge.
Hi.
In this instance, what the scientists are seeking to do is to try to get a handle on what the structure of those rings are by allowing light from this star to be attenuated or cut off by whatever material is in the rings, and this is the occultation that they're looking for. So as the spacecraft flies around the planet, the light from the star would be blocked by whatever material is there, and that occultation will help them to determine what the size and density of the ring material is.
Can you give yes, hi, Jack Horkheimer, the star hustler from the Miami Planetarium.
Seeing this picture tonight, it was kind of interesting. The thing that brought to my mind immediately was that almost from the very beginning, when this planet was discovered back in 1846, there were reports of people seeing rings, but they all turned out to be fantasies and unconfirmed. And as recently as in the past 10, 15 years, there have been several instances where rings have been detected, but again, unconfirmed. They weren't sure if they were rings or satellites. And so tonight we're seeing some fascinating instances of a confirmation of things that were suspected over 100 years ago.
Jessica.
Maybe we should explain to our viewers at home that in the lower right-hand corner of the picture, they can actually see the time when the picture came in, where it says 2:37. That means the 2:37th day of the year, which is tomorrow, but the time being Greenwich Mean Time, where it says 04:10. That's Greenwich Mean Time. So it's really 2:36 our time, 12:10. So that picture came in at 12:10 EDT, Eastern Daylight Time. So it's right now about 6 minutes old.
All right, and
so it's a real-time picture.
And it left Neptune.
It left Neptune 4 hours and 6 minutes ago.
All right, now perhaps you could walk us around the rest of the frame and tell us what the words mean.
Well, as far as one can see, some writing may be cut off at the home sets. Mm-hmm. On the top, of course, it says Neptune. That's the main object, even if we are looking past Neptune right now to that star, Sigma Sagittarii. And on the left side from Neptune, it says RLTM. That means real time. So that is transmitted from Voyager in real time without being recorded on the tape.
All right, and
then it says Voyager 2, which is clear. And on the bottom, there are some technical information. The range, for example, to the Neptune is 275,000 miles there. The scale is 15,000, which means it's a width across the frame, and so on.
Thank you, Jessica. Joyce Town from the Franklin Institute Science Museum has some more information about what we're seeing in the digital TV display.
Mm-hmm. Over on the right-hand side of your screen, you're looking at two boxes now that are called histograms. And they're charts of pixels, and they show the different gray levels of the images. The top histogram shows the gray level and the pixels, the way they arrived at Jet Propulsion Lab, and the bottom histogram shows what has been done to the image and the way it's being currently displayed. And you'll be noticing tonight that all the images you see, or most of them, will be in black and white, even when we get to some of the planet and moon images, and that's because the colors will be added later on.
Now, so some of the photographs that we have seen of Neptune in color, though, have been then processed at some length. What's involved in that processing?
Well, what's involved is taking some images that have been shot through different filters. There are several different color filters on Voyager's TV cameras, and by taking many of those images of different colors and putting them together with some computer equipment, you can get the colors and also some false colors that help you better understand the planet.
Now, what do you mean by a false color?
Well, sometimes you put false color on an image to help let different parts of the photo stand out, different things that you want to look at in the photo.
Now, if somebody wanted a photograph for themselves of Neptune as a souvenir of this voyage, is it possible to obtain these from NASA?
Yeah, you could probably wait a while until more photos become available, and then either call or write to the NASA Education Office that's nearest to you. And here in the Delaware Valley, where we are this morning, the nearest center is the Greenbelt, Maryland Center. It's called the Goddard Space Flight Center.